Hey everyone, welcome back. So in this video, what we're going to do is I'm going to give you two practice problems on using Snell's law. All right, so the first one we're going to use to solve for the second index of refraction, or the unknown index of refraction, and then the other one will solve for an unknown angle. In that case, it'll be the angle of refraction. Okay, so the first problem is this. So I've got a beam of light in crown glass entering at an angle of 28 degrees. Okay, and then it refracts into medium X, that's our unknown medium, we don't know what it is, at an angle of 22 degrees. All right, so how are we going to solve this? Well, Snell's law, okay? Snell's law. Now, as I'm writing Snell's law down on my board so I can go through the problem, it's interesting to note that the angle of refraction, that second angle, the angle in medium X, is smaller than that of the crown glass, right? It goes from 28 degrees as measured by the normal to 22 degrees as measured by the normal. So what that means is we should get an index of refraction that is larger than that of crown glass, okay? So here's our setup. N1 sine theta 1 equals N2 sine theta 2. Okay? So our ones, N1 sine theta 1, will be all the information in the crown glass. So the index of refraction of crown glass and the angle in crown glass. Okay? So how we know the index of refraction of crown glass? Well, you need to go to your reference tables. Okay? On your reference tables, you look at crown glass, you'll see that, oh, it's 1.52. So you plug in 1.52 times the sine of 28 degrees equals unknown index of refraction times the sine of 22 degrees. Okay? Well, now we're going to do our division. N2 equals 1.52 times the sine of 28 degrees divided by the sine of 22 degrees. Okay. Make sure that your calculator is in degree mode so you can calculate this properly. And we find that your N2 is 1.90. There's some decimals that I rounded off. I think it's like 1.904, something like that. So I just rounded to 1.90. And that's it. That's all there is to it. Okay, nothing crazy you have to go into for that. And just as we expected, the index of refraction of our medium X is larger than that of crown glass. Okay, which makes sense again because our angle went down, our angle got smaller. The wave bent toward the normal. Okay, so that's one example. And now let's go with another example. Okay, now in this case, we're going to be trying to find the angle of refraction. So we're going to be looking for that theta. Now that is going to require one extra step, okay, which we'll get to once we get there. Now, I'm going to change the mediums. Okay. In fact, I'm even going to do this, just give myself a little bit more space here. Just move that line over, just a scotch. Okay, so in this case, our original medium is going to be sodium chloride, NaCl, and our angle is going to be 34 degrees. Okay. And we're going to have this salt, this sodium chloride, go into diamond. Okay, so it's going from sodium chloride into diamond. And we want to know what is the angle that it's going to refract at, which I don't have the thing because I don't know. What's it going to look like? We'll see. Huh? All right, now let's use Snell's law, right? N1 sine theta 1 equals N2 sine theta 2. Okay. So we need the index of refraction of our sodium chloride. How do you find it? Once again, your reference tables. Okay, and you'll find that the index of refraction of sodium chloride is 1.46. So plug that in, 1.46 times the sine of your 34 degrees. Index of refraction of diamond, again on your reference tables, 2.42. Okay, times the sine of your unknown angle. Okay? Well, do a quick division. We'll see that the sine of theta 2 equals 1.46 times the sine of 34 degrees divided by 2.42. Okay? So, what next? Well, we're not looking for the sine of theta, we're looking for theta. Okay, so we need to do something with this sine to get rid of it. Well, if you remember from one of your math classes, we're going to do the inverse sine. Okay, sine, okay, 1.46, sine 34 degrees. You can calculate that ahead of time if you want. I just didn't do it, so I don't have that part memorized. It looks like this. So on your calculator, that would be second sine. You hit the second button, you hit the sine button, you get this, then you can plug in whatever you have for this. Okay? Do a quick calculation in your calculator, and we find that your angle of refraction is 19.7 degrees. Okay? Which again makes sense. The index of refraction for sodium chloride is smaller than that of diamond, so we expect it to bend toward the normal. Okay, so that is that. Those are the two most common ways you can look at using Snell's law to calculate either the index of refraction of an unknown medium or the angle. It could be the incident angle if you know the refracted information, or the refracted angle if you know the incident information. Okay, so I hope that helped, and I'll see you next time.